Okay, welcome to part 3, guys, where we're going to look at finding the equation of a line in 3 dimensions, okay? Now, you know how to find the equation of a line in 2 dimensions. It's y equals mx plus c. This is called the Cartesian equation of a straight line. But we can also define lines as a vector equation, okay? Which is useful because it's easier to do that in 3 dimensions than it is by using a Cartesian equation. We can use a Cartesian equation. I'm going to show you that as well. Okay. Now let me show you how you can define a line using vectors. Right, here is a point O, and here is a line, and A lies on the line, and the direction of the line is B1, B2, B3. Okay. Now what we do is we say, okay, let's start at O and let's get to the line. So let's find a point that is on the line. Okay, point A. And how do I get there? I start at O and get to A, so I need to go on OA. So that's going to have position vector A1, A2, A3. So start at O and get to the line. Then what I'm going to do is I'm simply going to travel in the direction of the line. Notice that I'm top to tail. So I'm going to travel in the direction of the line, B2, B1, B3. But what I need to do, if I want to get to any point I like, I need to travel some distance in that direction. So I can control the distance that I travel by simply multiplying it by lambda, which is some value. So so if I want to get this point exactly, I will travel a specific value of, I will pick a value of lambda that gives me a magnitude that takes me to the point R. Okay, so we can write it like this. This is the vector equation of a line. So it's a point on the line plus lambda times the direction of the line. Okay, another way of writing it, and the way you'll see it on your formula book, is R equals A plus lambda B. So any point on a line is a known point on the line plus a certain distance in the direction of the line. Okay, I hope that makes sense. So this is much easier to think about in 3 dimensions when you do it like that. Okay. So we can find the vector equation of a line that passes through A and B. So here's A, here's B, here's my line. Well, I need to know 2 things. I need to know one point on the line, which I know 2, and I need to know the direction of the line. Well, the direction of the line is AB, and AB will be OB minus OA. So that's going to be minus 1, 3, 2, minus 1, 2, 1, which is going to be minus 2, 1, 1. So that is the direction of the line. So the equation of the line is going to be x, y, z. Any position vector on the line is going to be equal to a point on the line, 1, 2, 1, plus lambda times the direction of the line. Okay, that is the direction of the line. Now, I said that this bit here must be a point on the line. So it would be equally correct to say this. Minus 1, 3, 2 plus lambda minus 2, 1, 1. Okay, let's say you wanted to know what this point on the line was. Here is O. Well, if I use the first equation, what I'm saying is go here and then travel this distance. So I'd have to make lambda quite big. If I use the second equation, I said I'll go to B. Well, lambda doesn't have to be quite as big. So all it will do is change what values of lambda bring you to a certain point. Okay? Remember, lambda could be negative because we may want to sort of go the other direction on the line as well. Okay, so I hope that makes sense. There are infinitely many correct answers, but it just will change what values of lambda give you certain points on the line. Okay, Have a go at B. Okay, B, direction will be CD, which is OD minus OC, which is 0, 1, 3 minus 3, 1 minus 1, which is minus 3, 0, 4. So XYZ is equal to a point on the line, 0, 1, 3 will do for me, plus some amount of direction in the line. Direction of the line. Okay, there's the answer. Now, as I said, it is possible to use this vector equation of a line to also write the Cartesian equation of a straight line, but also what we call parametric equations of a straight line. Now, parametric equations is just defining what x is in terms of another parameter, which in this case is lambda, okay? And y and z, define them in terms of lambda. So it's basically just splitting it up. So we can basically say x is equal to a1 plus b1 lambda, y is equal to a2 plus b2 lambda, z is equal to a3 plus b3 lambda. This is the parametric equation of a straight line in 3 dimensions. Okay? So basically, if I know a direction vector, let's say 1, 2, 3, and I know a point on the line 4, 5, 6, and I know lambda is 2, then I can find out where my x value is going to be. So, you know, I can find where this point on the line is. It's going to be 4 plus 1 times 2. Y is going to be 5 plus 2 times 2. And Z is going to be equal to 6 plus 3 times 2. Because remember, this I said was the direction of the line. This I said was a point on the line. So my x value at that point is going to be 6. Y would be 9. Z would be 12. So we would know that the point 6, 9, 12 would exist on such a line. Okay? So that's parametric. Now, the Cartesian equation of the line is simply a rearrangement of the parametric equations to make lambda the subject. So lambda must be equal to x minus a1 over b1. Lambda must also be equal to y minus a2 over b2. And lambda must also be equal to z minus a3 over a3. Okay, that's just a rearrangement of these 3 equations here. So if all 3 of them are equal to lambda, it stands to reason that x minus a1 over b1 is equal to x minus a2 over b2, which is equal, y, which is equal to z minus a3 over b3. Okay? This is the Cartesian equation of a straight line in 3 dimensions. In 2 dimensions, it's simply y equals mx plus c. But it's this for 3 dimensions. Okay? And you should be able to convert between the 3. Let's say I had a Cartesian equation of a line that was like this. X minus 1 over 2 equals y equals z plus 1 over 3. Okay? Just bear in mind, this is the point on the line. Okay, so I've got a point on the line that's going to be 1, 0, minus 1. And this is the direction of the line. There we go. So the direction of the line is 2, 0, 3. So my vector equation of the line is x, y, z is equal to 1, 0 minus 1 plus lambda times 2, 0, 3. That vector equation must be the same as this Cartesian equation. And in parametric form, we can say it's x equals 1 plus 2 lambda, y equals 0, z equals minus 1 plus 3 lambda. Okay, so Cartesian, vector, parametric. You need to be able to convert between the three. Here is what you get in the formula booklet. Okay, so remember these facts. You don't need to remember the formulas, you need to remember the facts. This is a point on the line. This is the direction of the line. Point on the line, direction of the line. Okay? Right, so here's a nice, easy, straightforward question. Stop your video and have a go first. Okay, so the vector equation of the line, very simple. X, Y, Z is going to be equal to a point on the line plus some amount in the direction of the line. Okay? And parametric form is going to be equal to x equals 1 plus 4 lambda, y equals minus 2 plus 5 lambda, z equals 3 minus 6 lambda. Cartesian form is going to be x minus 1 over 4, which is equal to y plus 2 over 5, which is equal to z minus 3 over minus 6. So you should be able to convert easily between the three of them by understanding, you know, the fact that this is a point on the line, this is the direction of the line, so on and so forth. Point on the line, direction of the line. Okay, I'm going to